Assalamualaikum warahmatullahi wabarakatuh. First of all, I will be introducing myself. My name is Talitha Amalia Suherman. In this chance, I will be explaining about linear algebraic equation methods. First is the Cramer's method. The Cramer's rule is a method that's used to uses determinants to solve systems of equation that have the same numbers of equation as variables. Here's an example for the use of Cramer's method. We know three equations as written here. X minus y plus 2z equals to 3. X plus 2y plus 3z equals to 4. And 2x plus y plus z equals to minus 3. First of all, we will be rewriting those equations as matrices. And then we determine the determinant of that matrix. We first find out the determinant for the D matrix, which contains 1, minus 1, 1, 2, 3, 2, 1, 1. And we can get the result, which is minus 12. Then we search for determinant X, then determinant Y, and lastly determinant Z. From all these determinants, we will be able to find the X, Y, and Z by dividing the determinant X, determinant Y, and determinant Z with the first determinant we have got earlier. The next one is Gauss elimination method. Gauss elimination is a process for finding the solutions of a system of simultaneous linear equation by first solving one of the equation for one variable in terms of only the others, and then substituting this expression into the remaining equation. So an example of the use of this Gauss elimination method is as written here, which we know it is given three equations: x plus y plus z equals to 2, x plus 2y plus 3z equals to 5, and 2x plus 3y plus 4z equals to 11. To find the solution for this, we write these equations in matrix form, as we also done in the Cramer's method. Then we subtract R1 from R2 to get the new elements of R2. From this, we get the matrix become 1, 1, 1, 0, 1, 2, 2, 3, 4, and 2, 3, 11. That will then become 1, 1, 1, 0, 1, 2, 0, 1, 2, 2, 3, 7. Then we will subtract R2 from R1 to get the new elements. After that, we now subtract the R2 from R3 to get the new elements of R3. Here, we got the last equations in form of x minus z equals to 1, y plus 2z equals to 3, and 0 equals to 4. That means there is no solution for the given system of this equation. The next one is the Gauss-Jordan method. The Gauss-Jordan method is similar to the Gaussian elimination process, except that the entries both above and below each pivot are zeroed out. After performing Gaussian elimination on matrix, the result is in row echelon form, while the result after the Gauss-Jordan method is in reduced row echelon form. For example, we have two equations, x plus y equals to 7 and 3x plus 4y equals to 11. To find the solution of these equations, we first rewrite the augmented matrix for the system as follows. Then we will multiply the first row by -3 and add to the second row. After that, we divide the second row by -3 and then we get the matrix as written. And finally, we multiply the second row by -3 and add to the first row, and we get the matrix 1, 0, 0, 1, 1, 2, which means x is equal to 1 and y equals to 2. And last but not least is the Gauss-Seidel method. The Gauss-Seidel iteration method is an iterative technique used to solve systems of linear equations. It's often employed for solving large systems of equations in numerical analysis and scientific computing. In each iteration, it updates the value of the variables one by one, using the most recent values of the other variables. The iterative process continues until the desired level of accuracy is achieved. Gauss-Seidel is one of the several methods for solving linear systems, and it's particularly useful for systems with special properties, such as diagonally dominant matrices. Here is an example for the application of this method. We have 4x1 minus x2 minus x3 equals to 3, and 2 minus 2x1 plus 6x2 plus x3 equals to 9. Then minus x1 plus x2 plus 7x3 equals to minus 6. At each step, given the current values x1, x2, x3, we will be solving for x1 k plus 1, x2 k plus 1, and x3 k plus 1, which could be written like that. To compare our result from the two methods, we can choose x0 equals to 0, 0, 0. When we find x1 equals to x1, 1, x2, 1, x3, 1 by solving, for x1, 1, minus 0 equals to 3. Minus 2x1 plus 6x2, 1 plus 0 equals to 9. And minus x1, 1 plus x2, 1 plus 7x3, 1 equals to minus 6. We will first solve for x1, 1 in the first equation and find that x1, 1 is equal to 3/4, which is equal to 0.75. We then solve for x2, 1 in the second equation using the new value of x1, 1, which is 0.75, and find that x2, 1 is 9 plus 2 times 0.75 divided by 6, which is equals to 1.75. Finally, we solve for x3, 1 in the third equation using the new value of x1, 1, 0.75, and x2, 1, 1.75, and find that x3, 1 is equals to minus 1. The result of this first iteration of the Gauss-Seidel method is x1, 1, x2, 1, x3, 1 is equal to 0.75, 1.75, and minus 1. We will iterate this process to generate a sequence of increasingly better approximations. x0, x1, x2, and find results similar to those that we found for example 1. If it's written in a table, it will look something like this. And at the right part of the table, we could see that the number of the errors for every iteration that we've done kept on increasing until it reaches 0%. That is all from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.